evening and you're watching my channel Bonding with Chemistry for the series Important or Expected Questions for Term 2 for Chemistry for the upcoming board examination scheduled for 10th of May. So in this video, I'm going to take up a topic, allotropes of carbon. Now this topic is not very important or relevant because it is given in orange box. There's a couple of questions that might come from here. The chances are extremely slim and I'm not going to mark this topic as important. Alright, so we are going to complete this topic by 5 or 6 questions that will help you to answer any question that might come up from here. So I've taken up all possibilities of the kind of questions which might be framed from this topic of allotropes of carbon. I repeat, the topic is not important. So let's begin. The first question is, what are allotropes? Name 3 crystalline allotropes of carbon. Now you've not been told about crystalline and amorphous allotropes. So even if it's a crystalline or allotropes, you have to mention the 3 allotropes that I'm going to discuss right now. What are allotropes? A direct question. Allotropes are 2 or more forms of a chemical element that occurs in the same physical state. That means if you're talking about the 3 allotropes of carbon, graphite, diamond, fullerenes, they are 2 or more forms of the same chemical element. All of them are the forms of carbon. The only difference is arrangement of atoms. How carbon atom is bonded in graphite, diamond, fullerenes is going to decide their physical properties, but all of them are going to have the same chemical properties. Like if I'm going to burn all of them, fine, they're all going to burn in oxygen to give rise to carbon dioxide. Clear? So you need to just remember that allotropes differ in their physical properties. Why? Because arrangement of atoms is different, but they have the same chemical properties because they're made up of the same chemical element. So this is the definition of allotropes, and these are the 3 allotropes of carbon. It's a direct question. Chances of this question is almost 0. Moving on to the next one. These are all reasoning questions now. Diamond and graphite are allotropic forms of the same element carbon, right? But they differ in their characteristic. How will you account for this? I did this question just now. They differ in their characteristics because the arrangement of carbon atom is different. Now I'm going to quickly explain you the structure of diamond and graphite. Nobody is going to ask you in your board examination to draw these structures. I'm doing it so that you are able to understand the reasoning questions which I'm going to discuss a little later. Now graphite has hexagonal layer structure. You know hexagon means 6 sides. Don't tax yourself. You are not supposed to remember how to draw the structure. I'm just drawing this is one layer. Similarly, you have another layer and another layer and so on. So we are going to curtail it to just 2 layers, something like this. All these points, let me show by different colors, they're carbon. Okay, they're all allotropes of carbon, so they're only made up of carbon atoms arranged in different manners in both graphite, diamond as well as in fullerenes. Similarly here also, you can do that, right? Now look, carbon has atomic number 6, configuration 2, 4, 4 valence electron, 1 here, 2 here, 3 here. The 4th one I am showing by cross is free. It's not bonded. If something is not bonded, it is free. So you can see that out of 4 electrons, one of them is free and it is mobile electron. It is free to move. Now I've told you in my earlier videos that free electrons and ions are charge carriers. So we can say graphite has free electrons or delocalized electrons, right? And therefore this is going to act like a good conductor of electricity, although non-metals are poor conductors. Right? If somebody asks a question in board, why it is a good conductor? Definitely it has to have free electrons or ions. Now the next thing is, now these layers, can you see this is the first layer? Let's say this is the second layer. Now these layers are held together by weak forces. There's a name for those forces called van der Waals forces. You don't have to remember right now at this point of time. They are held together by weak forces. So they can slide over each other. They can just move this way and this way. Fine. And therefore graphite also acts like a good lubricant, greasing agent. Alright. So this is how the carbon atoms are arranged in graphite. It's a rough structure, you don't have to remember. Just remember the arrangement of atoms in graphite, fullerenes and diamond is going to be different and therefore they are allotropes. Right? Coming on to diamond. Diamond instead has a carbon attached to 4 more carbon. Carbon has 4 valence electrons and all 4 valence electrons are bonded. They are not free. And therefore, diamond is a poor conductor of electricity, just like other nonmetals. Alright? So you can see here, it's a form of a tetrahedron. There you have hexagonal and here you have tetrahedron. So you see that the arrangement of carbon is different in both diamond and graphite, and hence they differ in their physical characteristic. Alright, so your answer is this. At this point, if you're not able to remember the structure, perfectly fine. This is a topic in orange box. There's so many other significant things that has to be asked from this chapter, that can be asked from this chapter. And the weightage is just 5 marks. So if one question comes from versatile nature, the other from whole other series, 2 plus 3, gone. Alright, so don't spend too much time on this. Let's move on to the next one. Now you know the structure, you'll be able to do these reasoning questions. Why graphite is a good conductor of electricity, whereas diamond is a poor conductor of electricity? Even if you do not know the structure, just remember, for good conductor of electricity, you have to have free electrons or ions. Here you can write down graphite has free electrons. Use the word mobile, free or delocalized, whichever word suits you. I'll go for class 10 level as free electron. That's easy to remember. Graphite has free electrons, or you can remember mobile because it can move, and thus it's a good conductor of electricity. Why diamond is a poor? Because diamond has no free electrons. All 4 electrons are bonded. Right? The same question can be put up in this format. Why graphite, unlike other nonmetals, is a good conductor of electricity? I told you nonmetals are generally poor conductor of electricity. Exception is graphite. Why? Because it has free electrons to conduct electricity. Another way of this question can be, a boy sharpens a pencil at both ends. Do not get scared by looking at the length of the question. Just read carefully, read it twice, and you'll be able to get the answer. A boy sharpens a pencil at both ends and then uses its black end to complete the electric circuit. That part is over. The question mark should not be there, it should have been full stop. Will the current flow through the electric circuit? Give reason for your answer. Name the black substance of the pencil. You have learned in your lower classes that the black substance of the pencil, if I have to show you with the help of a figure, is nothing but graphite. The second thing you have learned is graphite is a good conductor of electricity. So obviously the circuit is complete, right? And therefore the current will flow. Will the current flow? The answer is yes. Give reason for your answer. Because graphite has free electrons, mobile electron, delocalized electron, and thus is a good conductor of electricity. Name the black substance of the pencil. It is graphite. You can write down carbon. Even if you write carbon, you should be getting marks, but be specific, because you know carbon exists as graphite, diamond, and fullerene. Alright, let's move further. Why is graphite used as a lubricant? I told you the layers are held together by weak forces of attraction. You don't have to remember the names of that forces, and thus they can slide over one another. And if they can slide over one another, that makes it a very good lubricating agent. Let's go on to the next question. Why is C60 fullerene called bucky balls? Now you must have read that fullerenes are a class of compounds. C60 is just one example which is there in your course, and with love, with nickname, you can say its nickname is bucky ball. Why it is so called? Because this was the dome which was constructed by the architect Buckminster Fuller. And when C60 was discovered, it resembled like this. And therefore, after the name of the architect, C60 was called as bucky ball. Or C60 fullerenes were called as bucky ball. Bucky formed this, the first name, and then you have the ball because it resembled like a soccer ball with pentagons and hexagons. You've seen soccer balls, right? If you want to study more about allotropes, which I will not suggest you at this point of time, you can always refer to my video. But that is exhaustive. You do not require. I've covered up all the questions from here. In my next video, I'm going to talk about hydrocarbons and its type, alkanes, alkenes, alkynes. So stay tuned to my video. I know as the time is passing by, you are a little nervous, but no, you have all prepared well. And once you are through with this question answer round, I'm sure in chemistry you'll be able to make it 10 on 10. So, my dear students, I'm going to wait for you in the next video. Until then, take care.